Now let's do one where we go backwards, where I give you the probability, and now you're going to give me the sample mean that would give us that probability. So we're going to use our inverse z-score here. So let's say the commute times to get to school have a population mean of 32 minutes, a standard deviation of 9. If we take a random sample of 16 commuters, what mean commute time in that sample would mark the top 5% of possible samples coming out of that distribution? So we know that the population has an average of 32, but we want to know what is the possible sample mean that would represent the top 5% of the longest commute times, the top 5%. When we do this, we always need to take a left tail probability to our spreadsheet to get the z-score that represents a 5% right tail. And so we can always get the left tail by doing 100% minus the right tail. So we know the left tail has to be 95% if the right tail that we're concerned with is 5%. And so we're going to bring 0.95 to our inverse distribution z-score spreadsheet. And once we find this z-score, it will and we type in the left tail of 0.95, that automatically is the same z-score for a right tail of 5%. So I'm going to go take that left tail probability of 0.95. And I'm going to put this here so I don't forget it, 0.95. That's the left tail that I want. And now we'll get the z-score equals norm.s.inv. And now I'm going to click on the left tail. And we will see 1.6449. 1.6449. 1.6449. Okay. So we got the z-score we needed. We're not done yet, but that's the biggest part. We have to find the z-score that means a 5% right tail or a 95% left tail. Okay, that z-score represents both of those tails. So now we have a new formula to work backwards to get a sample mean. We're going to take the population mean plus the z-score times the standard deviation over the square root of the sample. That part, dividing by the square root of the sample, is the only new thing from this week compared to last week so far. So to find the sample mean that represents the top 5%, we're going to take the population mean plus the z-score we just got times the standard deviation over the square root of the sample. So 32 plus the z-score times the standard deviation divided by the square root of the sample. And so if we took a sample of 16 people, that the 5% of those possible samples would have a mean of 35.7 minutes or above. So the top 5 possible sample means we could get from a 16 numbered sample is going to be 35.7.